be tens digit now. And nowadays, this is there were cases in which usually students get 2 questions out of tens digit, not 1 but 2. So, okay, just a quick revisal. We have A, B, C, D, a number with the 4 digits. This is unit digit. This is tens digit. This is 100 digit, and this is thousands digit, right? And we are just finding this digit. And one more thing, the question could be asked, what is the tens digit? And a question could also ask the value, what is a reminder when we divide that by 100? When we are dividing that any number by 100, we are just finding the last 2 digits of that number. And when we are dividing by 10, we are just finding the last digit of that number, right? So question could be asked in form of exactly finding the tens digit, or what is a reminder when we divide that by 100. In unit digit, we just know the cyclicity from 0 to 9, right? But in tens digit, things are a bit complicated. We will just see the common scenarios, because in all of this, most of the scenarios, there is no common pattern forming. We will just see 4 to 5 scenarios, which are pretty common in exam. Okay, so first one is when we have 11. And one more thing, in unit digit, let's suppose we take 7, 1, 7, and 7, 2, we are just multiplying this digit with same. But in tens digit, we'll multiply the 2 digits. For example, 11, 1 is 11. What is 11 power 2? That is 11 into 11, 121. What is 11 power 3? That is
121.
121 into 11. That is something 31, and do 31. 11 power 4 is 31 into 11. That will end with something 41, right? So the pattern is like 1, 2, 3, 4 up to 0, and afterward it will again repeat 1, 2, 3 up to 0. So in case of 11, we have cyclicity of 10. 1, 2, 3, 4, 5, 6, 7 up to 0, 1. Got the point? This is for 11. Shall I move forward? Okay, the first one was 11. Now the second one is for 6. What is 6 power 1? This is, we are considering the tens digit, right? So we will write this as 06. What is 6 power 2? That is 36. What is 6 power 3? That is 36 into 06. What's the answer? This will end with 16. 6 power 4 is 16 into 06, and this will end with 96. Next one is 76, 56, 36. So in this case, the afterward, this will repeat 36, 16, 96. So this is excluded from the cyclicity. This is not, this is first, just for example, if you ignore this, after this, there is a repetition of 5. 3, 1, 9, 7, 5. Again, 3, 1, 9, 7, 5, right? So first one, then 5 repetition, then 5 repetition. The cyclicity of 5, with one exception, that is 1. Not 1, that is 0. Got the point? This is exception. Afterward, there is cyclicity of 5. 3, 1, 9. For example, let me give you an example. If I say, what is the tens digit of 6 power 17? Just quickly, what is the tens digit of 6 power 17?
6.
What is the answer?
1.
6.
6.
Yeah.
1.
Tens digit.
I'm asking about tens digit.
6.
3.
3. How that is 6?
Oh, okay. Sorry.
That is unit digit. So you can write this as 6, 1 plus and multiple of 5 is 15 and 1. This is for the 0. This is the exception. This is a multiple of the cyclicity. And this is 1, which is reminded when we divide this by 5. And that is 3. That's why the tens digit for this scenario is 3. Got the point?
Would you please repeat how did you divide 1 plus 15 plus 1?
The thing is that the first, this exception, because this is not involved in the cyclicity, right? So we have actually we have 6 power 17, right? And so I wrote this way, that 1 for the exception and next one is the multiple. We have cyclicity of 5, right? So I want a value that is a multiple of the cyclicity less than the actual value. What is that value? That is 15. And what is left here? 1 is left, right? So from now onward, if we divide by 5, so what is the remainder? That is 1. So I just pick the first value. It is just like in this pattern, 0, then 31975, 31975, 31975, and 3. This is what we are just find out. This is for the first one, this is for the 15, and this is just the 17th, which we just find out.
Yes, for that.
Got the point? This is just for the exception, and this is just cyclicity. And why I did it, because I want some multiple of the cyclicity. That's why I just made this 15. Got the point? If I divide this with the cyclicity value, which is 5, the remainder is 1, excluding this thing, right? Okay, so we have just seen the cyclicity for 11, 6, and 2 more. And next one is for 7. This is very simple. First one is 0, 7. Second one is 0, 7 into 0, 7, which is 4, 9, 7, 1, 7, 2, 7, 3, 7, 4, 7, 5. Okay, so next one is 4, 9 into 0, 7. That is 4, 3. And 4, 3 into 0, 7. That is 0, 1. Afterward, this will repeat as 0, 7, 4, 9. So there is cyclicity of 4. 0, 4, 4, 0, 0, 4, 4, 0, up to so on, right? 0, 4, 4, 0. Then again, same pattern will repeat. Got the point?
No, would you please repeat?
Where is the confusion? When we have 7 power 1, that is exactly 0, 7, right? We are considering the 10 0. That's why I just wrote down 0 at start. Otherwise, this is just 7. And for finding the 7th square, 0, 7, again we will multiply with the 0, 7. And we are finding the 10th digit. That's why I am considering 2 digits, 0, 7, not just 7. But if we are at time we are finding the unit digit, we just multiply with 7. But now I am multiplying with 2 digits because actually I am finding the 10th digit. That's why
Yes,
I will keep on multiplying with 2 digits. And now the last one is, for example, just to clear your doubts out, if I have 21, right? This is the last, and yep, plenty of question exam relevant to this. And we have some power of 21, a big power. Okay, so what is the cyclicity for 21? 21 power 21 is 21. 21 power 2 is 21 into 21, because we are finding the 10th digit. What is the answer? That is 4, 1. Some value ending with 4, 1. 21 cube is 4, 1 into 21. That is some value ending with the 6, 1. The next one will be 8, 1, then 0, 1. And the same pattern will repeat. Then again, 2, 1, 4, 1, 6, 1, 8, 1, and 0, 1. So the cyclicity is of 5 with 2, 4, 6, 8, and 0. 2, 4, 6, 8, and 0. So cyclicity is of 5 for these. Right? So you actually don't need to remember, but it's a better to remember for 21, 4, 6, 4, 7, because these are pretty much common. But if you not want to remember, just you can straightforward form this in exam as well. Just keep multiplying with the 2 digits, 21, 21, you will just get idea about the cyclicity of that in tens digit. Right?
May I know why you are writing down twice? First, we consider 24680. Okay. Then you again wrote down 24680.
This is cyclicity. There is a repetition. After this, after 0, 1, if you again multiply this value with 21, you will get a value that will end with 21. So there is a repetition of this, of 5 values in a tens digit for 21.
So both are same for 10 digit and unit digit.
For
In this case,
unit digit, you only need to consider the last value, but for tens digit, you need to consider both of these values. That's the only main difference in tens digit and unit digit.
okay.
Right? For example, if I ask you that we have 21 into 31, if you ask for the unit digit, just multiply 1 into 1, the answer is 1, that is unit digit. But in case of finding the tens digit, you need to multiply 21 as a whole with 31 as a whole. Then you will get the tens digit from this
10.
question.
Yes.
Right?
Yes, got that.
And here prime factorization won't help.
Prime factorization, I don't think so. Maybe, but
Okay.
don't go for that.
Okay.
And these 4 which we discussed, 11, 7, 6, and 21 are pretty much common. And besides, there are other as well, but there is higher complexity in case of tens digit. And in some, there is not even the cyclicity form. There is not even a repetition, right? So most of the time you will get out of these 4 in exam, but be prepared, there could be some sort of explosion in exam as well. Okay, so we have discussed this earlier, this as well. Yeah, just give the answer for this question. This is, I will say, a level 4 question.
Six.
B.
Yeah, D. 6.
So what's the answer to this question? B or D?
D for
D.
dog. Yeah.
Wow. And someone say B as well.
I think it is A, 0.
Oh, wow, another answer. Anyone for C
Yeah.
and E as well? First, tell me what is the cyclicity of tens digit for 21?
24680.
24680.
2, 4.
That is 2, 4, 6, 8, and 0. Right? Okay, but in power we are having 3 power 20. So how will you cater for this power?
Divisible by 5, I think.
Yes, exactly. So first tell what is the cyclicity of 3 for unit digit?
3971.
3971. And if we have 3 power 20, what is unit digit for that?
Is 3. Sorry, 1.
1.
That's 1,
1.
right? So actually we have 21, some power of 1,
1. Yes.
right? Now, what is cyclicity of 21? That is 5, right? So whatever the first digit is, if we divide this by 5, the result is always 1. Because whether that first one is 2, 4, 6, whatever the value is, the clue is because we are having the cyclicity of 5, and if we divide the power with 5, the result is always 1. That's why we will just pick this value. For example, we have 11, 21, 31, 41, whatever the values. If we divide these by 5, what is the remainder? Remainder is always 1.
Yes.
That's why the cyclicity to this question is 2. The tens digit for this question is 2. If I just change this question and make this 3 power, let's change this question and make this 21 3 power 15. Now just quickly tell what is the answer.
Four. C.
4,
C.
4 and
C. I chose 4.
yeah, perfect. Because the cyclicity of 3 is 3971. And if we divide 15 by 4, what is the remainder? The remainder is 7. The remainder is 3. And that's why we just pick 7, right? So 21, some value that ends with 7. If we divide this by 5, the remainder is 2. That's why we will just pick the second value.
Yes.
So whenever you got such question, there always a pattern. Like in this question, we have 5. So that's why there is no difficulty in finding this. But this could be twisted a bit, but we will see that part. Okay. So now let me give you another way. Quickly tell what is the answer to this question.
0.
0. Any other answer? 3.
0.
0. Okay. First of all, question is saying divide by 100. So you need to tell last 2 digits, not just the tens digit. Just keep this in mind. When you are dividing by 100, you are just telling the last 2 digits. Okay. So what is the value for 3 factorial? That is 6.
1 is 6. Yes.
What is 4 factorial? That is 24. What is 5 factorial? That is 120. What is 6 factorial? That is
720.
720. What is 8 factorial? You don't need to remember just 20 into 8. Just make this 20 into 8. The last 2 digits into 8. So what is the answer?
0.
20.
Please
60, right?
repeat.
I'm saying, okay, I'll hold for a second. Yeah. Okay, so I'm saying, what is the last two digit for 8 factorial?
720 into 8.
What is that value?
Last two digit are
The
60.
last two is
Not
yes.
we just left the 7 factorial. This is 3 factorial, 4 factorial, 5 factorial, 6 factorial. And what is for a 7 factorial? 20 into 7, that is 40. Just consider these two. And exactly what is the factorial of 8? That is 7 factorial into 8, right? So we are finding the last two digits. Just take 2 digits and multiply by 7. You don't need to see the whole as a whole. For 8, that will be 40 into 8. That will end with 20. And for the 9 factorial, that will be 20 into 9, which is 80. You're getting a
Yes.
point? So we are just considering 2 digits, right? You don't need to actually see whatever the length of these values, just see the last 2 digits. Okay, so now tell what is the sum of all of these values? 6 plus 24 plus 20 plus 20 plus 40 plus 20 and plus 80.
210.
210. And when we divide this by 100, what is the answer?
In
10.
Yes, that's it, 10. You got to find out how could the 10th digit concept be asked. One way is directly by saying that find the 10th digit, and the other way is by asking that reminder when we divide the total value by 100. I even got this.
So finally, we have to sum up the unit
Last two
and
digits.
digit.
Yes,
Last
last two
digit,
digits.
Okay.
Perfect. And 2 more questions for this. Leave this. I will share you and solve a pivot. Now just tell how can you solve this question? Okay, so what's the answer?
D.
D or B?
D. 70.
Yes, the answer to this question is 70. Anyone is still solving this question?
I found out for the unit digit, but couldn't attempt for the 10 digit.
Okay, so the question is saying, what are the last two digits? And one way is just keep multiplying and just come up with the last two digits. The other way is, how can we get last digit when we divide the whole value by 100? Exactly what we discussed a question earlier. Okay, so we have this value 63 into 35, 35 into 37 into 82 into 71 into 41. And to find the last two digits, just multiply divide these by 100. Okay, so the point is, first, just simplify this. What is 63? 63 is, just quickly tell me the prime factorization of 63.
337
into 7.
is for 7.
9 into 7. But 3 is here into 7, right? Into what is for 35? 5 into 7. Just keep 37 for intact for time being. What is 82? That is 41 into 2, then 71, then 41 divided by 100. One more thing, we have 5, 1, 5 and 1, 2. This means whatever the value is, we just keep 5 into 2 separate. We have 7 into 7 into 37 into 41 into 71 into 41 divided by 100, right? This will become 10. Now, one thing is sure that,
This is also 9, right?
yeah, 9. One thing is sure that the unit digit is 0. The next thing is we just need to find the tens digit. So how can you find that? Anyone?
So for the
Yes.
unit digit of the right hand side multiplication will be the tens digit of the
Yes.
whole number.
Yes. I'm saying, what is that value? 1. Listen, that is 1, 1, 1 for this. That is, just see the last digit, 1, 1, 1 into 7 into 7 into 7 into 9. And for this, the result is 1. For these, we have 7 cube, and the cyclicity of that is 7 is 7, 9, 3 and 1. And for this, the result is 3. We are left with 9 into 3, and 9, 3 is 27. So the last digit for this is 7. Whatever the value is, 7 into 10, this will become 70 over 100. That's why the last digit is 70.
Yeah, I just multiplied and found out.
You don't need to find out. It's just a cyclicity.
Why we are considering dividing by 100?
Just again see the question. What are the last two digits?
Yes. Okay.
Got the point? This is just exactly the same question which we discussed earlier. That let me move to the question. The question was this question: what is a reminder when we divide this by 100? In that case, we just got the last two values at our answer, right? That's why in the inverse, if we want to find the last two digits, just divide that by 100.